I'm Mrs. D. Shanti Challaya, going to take Unit 5 in this subject, which covers voltage regulators, multivibrators, waveform generators. The types of waveform generators using op-amp is classified as sine wave generator, square wave generator, triangular wave generator, sawtooth generator, and pulse width generator, which finds applications in many real-time systems and communications and embedded systems. First, now we will discuss the types of sine wave generators using op-amp and its principle of operation, followed by this. Sine wave generators produce low distortion sinusoidal signals for testing and communication systems. Before going to the principle of sine wave generators, we should know what is oscillator and its condition. The oscillator should has positive feedback and it should meet Borgesian criterion. Borgesian criterion states that the loop gain should be 1 and the total phase shift should be 0 degree or 360 degree. The types of sine wave generators, what we are going to discuss is RC phase shift oscillator and Wien bridge oscillator. Now we will discuss the principle of operation of RC phase shift oscillator. The RC phase shift oscillator is a linear electronic circuit that generates a stable, continuous sine wave output. It relies on an amplifying device such as op-amp or transistor. Here we use op-amp as an active device and a feedback network consisting of resistors and capacitors to produce oscillation. It uses three RC sections providing 180-degree phase shift, and the op-amp is operated in inverting mode, which produces another 180-degree, and total 0 degree or 360-degree phase shift is obtained, which meets the condition of oscillator. The operational amplifier is configured as an inverting amplifier, and this configuration inherently provides an additional 180-degree phase shift, meeting out the criterion and generates the continuous sine wave. The frequency of oscillation f naught is given as 1 by 2 pi RC into root 6. We will discuss the principle of operation of Wien bridge oscillator. The most popular low distortion sine wave generator uses lead lag Wien bridge network. It is an electronic circuit that generates stable low distortion sine wave typically for audio frequency testing. It consists of an amplifier and a frequency selective RC lead lag network that provides positive feedback. Here, the op-amp is configured in non-inverting op-amp configuration, which provides the necessary amplification. One branch features the resistor and capacitor in series, acting as a high-pass filter, and other features a parallel RC combination acting as a low-pass filter. The circuit is designed using the passive components R1, C1, R2, C2. The resonant frequency FR is determined entirely by the resistor R and capacitor C values in the lead lag network. At the specific resonant frequency, the feedback network introduces a 0-degree phase shift, allowing positive feedback to sustain the oscillation. The frequency of oscillation is given as 1 by 2 pi RC. The branch features a resistor and capacitor in series, and another branch has resistor and capacitor in parallel, which forms two arms, and other arms is formed by other two resistors R1 and RF. Thus, the Wien bridge oscillator produces a continuous sine wave and acts as an oscillator. The advantage is exceptionally stable frequency, very low harmonic distortion, and highly tunable across a wide range from few hertz to 1 megahertz. And the applications are in audio testing equipment, function generators, telecommunication, modulation circuits, and scientific research instrumentation. Now we will discuss the operation of next wave generator to generate a square wave. The square wave generator is an electronic device, the oscillator circuit, that produces a repetitive non-sinusoidal waveform alternative between high and low voltage levels. It is widely used as a clock signal in digital electronics, signal processing, and testing equipment. It is also known as a stable multivibrator. It is a free-running oscillator that switches continuously between two saturation states without any external triggering. The most common circuit is the stable multivibrator. It operates as a schematic trigger with an RC timing network. The capacitor charges and discharges between the upper and lower threshold limits of the schematic trigger. So the output automatically toggles between positive and negative saturation voltages. When we see the waveform, it shows the charging and discharging time of the capacitor. The output of the stable vibrator is a continuous square wave which consists of no stable state. It is the alternative between high and low levels of Vsat. It switches between plus Vsat to minus Vsat. Based on the capacitor charging and discharging, the output switches from plus Vsat to minus Vsat and minus Vsat to plus Vsat alternatively, and it generates a continuous square wave. The frequency is given as f0 is equal to 1 by t, where t is the period of oscillation. T is equal to 2RC into ln of 1 plus beta divided by 1 minus beta. Beta is the feedback ratio and it is given by R1 divided by R1 plus R2. The advantages of a stable multivibrator is high accuracy, excellent noise rejection, and good stability. We have discussed the various types of waveform generators, which finds various applications in PWM modules and design of function generators for high precision and high accuracy. The square wave with ultra low jitter up to 30 MHz or 60 MHz has been designed for the function generators. Thank you.